For question 3, we're into addition and subtraction of fractions. So again, when you see one of these problems, I need you to automatically ask yourself, how do you add or subtract fractions in general? Because these same rules are going to apply whenever we're adding and subtracting rational expressions. So if you ever forget your rules, think of a simple addition of fractions. Now remember, we need a common denominator. Here we already have one of 2, so we're going to add our numerators, but our denominator stays the same. So in the very first rational expression, I'm going to follow those same rules. The main difference is that we have to factor, but also, if you have a subtraction problem, one way to keep up with that subtraction is to go ahead and rewrite it as an addition problem by distributing your negative. So, when I distribute this negative, think of it as a -1 being multiplied by this fraction. I really only need to distribute it to my numerator. So now I have an addition problem. And my numerator has just changed signs. All right, once I have my subtraction rewritten as an addition problem, I'm then going to factor everything, just like we did with multiplication and division. All right, so my numerator in the first fraction does not factor, but my denominator does. X minus 6, x plus 1. Okay, and then my numerator here, we could factor out the -1. And I have x minus 6 in the denominator, which does not factor. Okay, keep in mind we're adding fractions here. So in order to add, we need a common denominator. So if I look at my 2 fractions, I have a denominator of x minus 6 times x plus 1, and then my other denominator is just x minus 6. So I need to get these to match. So my least common denominator can be found by including all factors of the denominators. Now, if I look at the first denominator versus my second denominator, the only thing missing in this denominator is an x plus 1. But mathematically, I cannot multiply just my denominator by x plus 1. I also have to multiply the numerator, because this way I'm not changing the value of my fraction. My fraction, if I multiply by x plus 1 divided by x plus 1, I'm really only multiplying by 1. So my LCD here is x minus 6 times x plus 1. Okay, so my first fraction I didn't have to change, but my second fraction I did have to multiply by x plus 1 over x plus 1. So now we have a common denominator. Once you have a common denominator, remember we add numerators, but our denominator stays the same. All right, at this point I can't just add these numerators because I have too many parentheses going on. If I look at my first fraction, the parentheses x minus 3, if I were to add it with my other fraction, these parentheses aren't necessary. However, if I look to my second fraction, here these parentheses mean that I'm multiplying these two things. So I am going to have to multiply this out. So we'll FOIL negative x times x is a negative x squared. Negative x times 1 is a negative x. Negative 3 times x is a negative 3x. And then negative 3 times 1 is a negative 3. My first fraction, we still have an x minus 3, and we're adding. Since we're adding our numerators, our denominator is going to stay the same. Now the only thing left to do, since my parentheses are all gone on my numerator, is to combine like terms. So here I have an x, negative x, so that's 0x, minus 3x, we have a negative 3x. Okay, then I have a negative x squared, and then I have negative 3 and a negative 3, which gives me a negative 6. All right, our denominator is x minus 6 times x plus 1. Now, although this is equivalent to the correct answer, most likely, especially if this were multiple choice, it would be written in standard form. So we would have our negative x squared first, then minus 3x, then minus 6, all divided by, and you can leave your denominator as x minus 6 times x plus 1, or you can actually FOIL that out, multiply out, and you get your denominator is x squared minus 5x minus 6. So either of these answers are okay. You also may have factored out your negative 1 on your numerator, which is fine as well. But if you went to try to factor this quadratic, there's no factors that multiply to 6 and add up to 3, so you'd be done at that point. Any of these are acceptable answers.